Good morning, I'm Radical Rick, and today on Extreme Science, we are going to try putting Diet Coke and Mentos in a vacuum chamber. I watched a video the other day, and this guy wanted to see what would happen if you put Diet Coke and Mentos in a vacuum chamber. Problem was, he had a smaller vacuum chamber, and he had made a comment at the end that it was really cool, but he had wished that he had a taller vacuum chamber so it wasn't limiting the experiment. Well, guess what? I have a 4-foot tall vacuum chamber, so let's give it a try and see what happens. Now, if you remember, when we drop the Mentos into the Diet Coke, it causes it to erupt really fast because it's releasing all of that carbon dioxide gas all at once. So why would we even want to put it in a vacuum chamber? Well, first off, because we can. Secondly, because we want to see what impact the atmospheric pressure has on the eruption of the Diet Coke and Mentos experiment. We've talked about it before, and if you remember, there's 14.7 pounds of atmospheric pressure all around us. So the question is, if we remove that atmospheric pressure, will it cause the eruption to be even bigger than it already is? Will it be the same? Or will something different happen? If we were to just put the Diet Coke by itself in the vacuum chamber, we could actually get it to boil at room temperature as well. Keep in mind that the Diet Coke also has carbon dioxide gas dissolved into the solution. As soon as we begin to reduce the atmospheric pressure, the carbon dioxide gas will begin to be released from the Diet Coke. So after 12.5 minutes, I'm pretty sure all of the carbon dioxide gas, or most of the carbon dioxide gas, has been released from this, and what was left there was just actually boiling from the pressure difference. But let's go ahead and test it out and drop in a Mentos. And as you can see, nothing happens. So again, will this actually cause the Diet Coke to erupt faster when we drop a Mentos into the Diet Coke inside of the vacuum chamber? Let's find out. So before trying the Diet Coke and Mentos in a vacuum, we need to see what it looks like under normal atmospheric pressure. Now, regardless of how many we put in there, as you can see, we got quite the reaction. But as we got up to 4 or more, you can see that there was so much pressure that it actually forced the top up and sprayed all over the wall, even though I was pushing down on it. So now let's compare them side by side so you can see the difference in the eruptions, as well as how much Diet Coke was left after each experiment. As you can see, all of the ones on the left were done at atmospheric pressure, and the ones on the right were done under a vacuum. We started out with 1 and went all the way up to 6 Mentos in each. Now, if you listen closely on this one with 6, 3 of the Mentos actually got thrown out during the initial eruption, and you can hear them hit the bottom of the vacuum chamber. I think that the coolest thing that I learned doing this experiment was that even though the initial eruption didn't spew out as much in the vacuum chamber, I was really surprised to see the second eruption on those that were done in a vacuum. As you can see, typically the ones with fewer Mentos had a larger second eruption since they contained more Diet Coke and carbon dioxide gas at that moment, except for the one with 6, since it blew 3 of the Mentos back out initially. Now, if we do a side-by-side comparison afterwards, you'll notice that there was the same amount of Coke left with only 1 Mentos, regardless of whether it was done in the vacuum or under normal atmospheric pressure. All of the rest of them, on the other hand, you can see that more Coke was expelled when done in the vacuum chamber with 2 or more Mentos. When doing this experiment in a smaller vacuum chamber, you could easily come to the conclusion that there was a larger eruption in the vacuum chamber since more of the Coke is typically expelled. But by doing this in a tall vacuum chamber, it is clear that although the initial eruption is larger under atmospheric pressure, the second eruption when done inside the vacuum chamber ends up expelling more of the Diet Coke in the end. Don't go anywhere, we've got lots more to come on the Wake Up Show.